Okay, this lesson is on stationary points. Stationary points are when the gradient is equal to 0. These are points when the tangent line is horizontal. So, like an example, if we have something like this, right here is a stationary point, right here is a stationary point because the slope at that location of the tangent line is going to be 0. Those points, this one right here, is considered a local maximum, and this one right here would be considered a local minimum. A stationary inflection, we'll learn about what that is a little bit later in the lesson. All right, so we have this graph, and its domain has been restricted from starting with x is -5 and ends when x is 6. All right, it says, what is the global minimum? The global minimum is referring to the point that is the lowest on the graph. Now, the local minimum, the local one, is where you have the hills and valleys. This right here would be considered the local minimum. All right, continuing, this one's asking about the global maximum. So we're talking about the highest point, which would be point D. And then the local maximum would be the top of the hill, like this, so point B. Skip that one. All right, so for this one, it's asking us to find the derivative. So if we've got f of x equals x to the third, take the 3, move it in front, so it is now 3x squared is our derivative. It says, at what point is the gradient equal to 0? Well, you could probably visually see it on the graph to the right, but if we wanted to figure that out, we would just make the gradient 0. Oops. And we just solve for x. So I divide both sides by 3. So I have x squared equals 0. Square root both sides, so x is 0. So we know that at 0, we know that x is 0. If we want to know what the y value was, we could plug it into here. 0 cubed is 0. So we know what's happening at this point. Right here is where our tangent line, our slope, our gradient is at 0. Now it says, what do you notice about this point? Well, this point is called stationary inflection. And what that means is this. Stationary inflection is the point that the curve changes its curvature or shape. So as we saw in the last picture, I could draw a pretty one. Basically at this location is when the graph changed shape. So it's known as a stationary inflection. Okay, so our next thing we're going to look at is using sign diagrams to help us figure out where we have local maximums and minimums and stationary inflections. So it says we can use a sign diagram of the derivatives, function's derivative to help identify stationary points. When looking at the derivative, if the signs switch, you have a local min or max. So these are the situations, okay? You're going to want to get this down. When it's a minimum, your sign diagram is going to go from negative to positive. When it's maximum, it's going to go from positive to negative. If your signs stay the same, that's when you have a stationary inflection. So as you can kind of just see over here, from positive to negative, that was the local maximum. When it went from negative to positive, that was the local minimum. And when it stayed the same, that was the stationary reflection. But once again, we're looking at that in terms of the derivative. All right, so let's take a look at a problem. All right, so first thing we want to do, since it asks us to find and classify all stationary points, so we're trying to figure out which ones are local mins, local maxes, stationary inflections. So we're going to create a sign diagram. To do that, we are going to find the derivative, because we're going to have that help us out. So f of x. Okay, so gain the derivative, put the 3 in front, 3x squared, put the 2 in front, 2 times negative 3x, put the 1 in front, 1 times negative 9 to the 0 plus 0. So we'll have 3x squared, 2 times negative 3 is negative 6x, 1 times negative 9 times 1 is negative 9. So here is our derivative. Now, just like last time, we can go ahead and find our stationary points by solving the derivative. You could do it by hand. In this case, you could factor this. You could use, go to the apps feature, go to Polysim 2, and use the polynomial root finder, whatever you prefer. I'm just going to do it by hand because it doesn't take that much time for me. So I'm going to factor out a 3 here. I'm going to factor this. Okay, so now I have my 2 stationary points to create my sign diagram. So I'm going to just put that over here. I have negative 1 and 3. Now, what I'm going to do is use my graphing calculator to figure out should I have plus signs or negative signs by graphing the derivative. So I'm just going to go to the y equals button. I'm going to make my y1 be my derivative, 3x squared minus 6x minus 9. When I do that, do that real quick with my calculator, 3x squared minus 6x minus 9, I'm going to graph. My graph is going to look like this. Right here is at negative 1, this is at 3. So to the left of negative 1, the graph is above the x-axis, so it's going to have a plus sign. So and then between negative 1 and 3 is below the x-axis, so it's a minus. And and to the right of 3 is going to be above the x-axis, so it's positive. So now that I have my sign diagram, I can now determine which of these are mins and maxes. So from the previous slide, if it went from increasing to decreasing, so plus to minus, that's considered a maximum. So we have ourselves a maximum going on. And if we had negative then to positive, that is a minimum. Once again, these are referred to local mins and maxes. So it's asking us to classify, which we've done, and find. We actually have to find the points. Now we know what the x's are. We found them through factoring or by using your calculator. I need to find the actual point, so I'm going to take negative 1. I'm going to plug it into the original problem and find its y value. When I type it into my calculator, I am going to find out when x is -1, I'm going to get myself 10. So that means my local max is -1, 10. Going to do the same thing. Now I'm going to do it for the 3. So I'm going to have f of 3, and when I type that in, I'm going to get -22. So my local minimum is 3, -22. We're going to tackle one more like this, I guess. So we got a really long one this time. So this is where we really want to let our calculator do the work for us as much as possible, especially when it comes to finding those stationary points. So we're going to go ahead and find the derivative. So the 4, we're going to move in front. So we have 4x to the third. We're going to take the 3, move it in front. So 3 times -2 is -6x to the second. Move 2 in front. -23 times 2 is -46x. Take the 1, move it in front. 24 times 1 is 24. X to the 0 doesn't matter. And then we get plus 0. So here is our derivative. Now, I don't want to try to solve this by hand, so I'm going to use the calculator. And once again, I'm going to go ahead and hit the apps button. I'm going to go down to Poly Sim 2. Then I'm going to go to the first one, Polynomial Root Finder. And now, since this time my highest degree is a 3, I need to set the order to 3. So I'm going to move it over, set order to 3. I'm going to hit next, and now I'm going to type in the polynomial. And -46, 24. Then I'm going to hit solve, and it lets me know that our stationary points are -3, 1/2, and 4. So I'm going to set up my sign diagram. All right. And this is where now I'm going to go ahead and take my derivative and go to y equals. I'm going to make my y1 be the derivative function. And I'm going to go ahead and type that in. Okay. And when I graph it, it's going to look like this, where this is -3, a 1/2, and a 4. So I can see to the left of -3, I am below the x-axis, so I have a minus. Just going to do that in green. And then when I'm between -3 and 1/2, I'm above the x-axis, so I have a plus. Once again, between 1/2 and 4, I'm below the x-axis, so I'm a minus. And then to the right of 4, I'm above the x-axis, so I'm plus. All right, so now that I have my sign diagram, I can see that the -3, reading from left to right, negative to positive, is giving me a local min, and then plus to minus is going to give me a local max, and then negative to positive is giving me a local min. So I'm going to get those stationary points by taking them and plugging them back into the original problem. So I will plug in the -3 first. When we type that all in, we're going to get -3 equals 0. I'm going to do the same thing with the 4 for the other local min. And once again, I'm just going to replace all those -3's with 4's, which is also going to give me 0. So my local minimums are going to be -3, 0 and 4, 0. Then I'm going to do the same thing for the local max. So I'm plugging in a 1/2. I'm just going to make it a decimal, 0.5 to the 4th minus 2, 0.5 to the 3rd minus 23, 0.5 to the 2nd plus 24, 0.5, and then plus 144. When I do that, I'm going to get 150.06. So my local max is 1/2 x, comma 1.105.06. All right, so this one is a bit different than the other, so I want to go over one like this. All right, so find and classify the stationary points just like before, but this time it's a little different. We have a x in the denominator, and when that happens, we have something called an asymptote, a location on the graph where the line just cannot pass. So we end up having an asymptote, at x equals 0, because you ask yourself, what number can you plug into x to make that denominator equal 0 where it couldn't exist? It's going to be 0 for us. So in our sign diagram, we're going to have an asymptote at 0. Now I'm going to go ahead and find the derivative, just like we've been doing previously. So we'll have 2x plus 2x to the -1. Once again, just that's a 1, moving it to the top makes it a -1. All right, going through the process, 1 times 2 is 2, x to the 0, -1 times 2 is -2, x to the -2, because you're always subtracting 1. We're going to end up with 2 minus 2 over x squared for our derivative function. Now we want to go ahead and we want to solve this by setting the derivative equal to 0. Now we can't really use polynomial sim finder because this is not a polynomial, so we have to solve this by hand. So I'm going to add the 2 over x squared to the other side. And so we're going to have 2 over x squared equals 2, because those cancel out there. That's really 2 over 1, so I can cross multiply. So I'm going to have 2 equals 2x squared. I'm going to divide both sides by 2, so I have x squared equals 1 square root. When I square root both sides, I will get plus and minus 1. So I have -1 over here and +1 over there. Once again, by going ahead and typing my derivative into the calculator and just looking at the graph, I find that to the left of -1, it's above the x-axis. Between -1 and 0, it's below the x-axis. Between 0 and 1, it's below the x-axis. And to the right of 1, it's above the x-axis. So this right here, once again, that's the asymptote. Went positive to negative, so this is the max or local max. Negative to positive, that means this is the local min. Once again, we can find those actual points by plugging in to the original function. So 2 times -1 plus 2 over -1, that is going to give you -4. So our local max is -1, 4. And then we do the same thing with the +1. we're going to get ourselves positive 4. So our local min is 1, 4. Okay, our last problem here. So it asks us to find the greatest and the least value. It's referring to the y values for the function on the interval from -2 to +5. So what it's basically saying is we have an endpoint that's at -2, comma, some y value, and then you have the other endpoint on the other side that's at 5, comma, some value. We probably have maybe some local mins and maxes in between, and we don't know how high or low they go, so we will have to find them to determine their y values. But real quick, I'm going to take this -2, I'm going to substitute it in to the original problem to figure out what their y values would be. To the third -6 squared plus 5. Okay, when I do that, I'm going to get -27. I'm going to do the same thing with the 5, and I'll get 20. So now I'm going to try to find the local mins and maxes to see if any of those numbers are, greater or less than what I've just found. Sorry, this is -20. All right, so I'm going to go ahead and find the derivative, put the 3 in front. I'll have a 2 here. 2 times -6 is -12. It'll be x to the first. The 5 makes a 0. So now I have the derivative. I'm going to solve for that to find my stationary points. This is a pretty easy factorable, so they have a 3x in common. So 3x times x makes 3x squared. 3x times -4 makes -12x. So 3x equals 0, x minus 4 equals 0, dividing by 3, adding 4. So now I have a sign diagram at 0 and at 4. Once again, if I take my derivative and plug it into my graphing calculator, I can see that to the left of 0 is above the x-axis, between 0 and 4 is below the x-axis, and to the right of 4 is above the x-axis. So that means I know this is a max, a local max, and this is a local min. So I know I have a local max with 0, a local min with 4. Then once again, I'm going to take these numbers, the 0, I'm going to plug it in to the x. When I type it into the calculator, it tells me that I get -27. I'm going to do the same thing. Sorry, I'm a liar. I get myself 5. When I plug in the 4, I'm going to get -27. So looking at my options here, I can see that my maximum value, my greatest value, is at 5, and my minimum or least value is at -27. So I can say the greatest value is 5 when x is 0, and my least value is -27 when x is -2 and x